Okay, good afternoon, everyone. Well, I am going to speak about the case study 2, the aquaculture plant. And I would like to provide a brief analysis of the return of the European Union investment in our idea. Why? Because sometimes when I see all the European projects where we have participated, I wonder if it was really worth for the European Commission, or if we have wasted the tax money from the European citizens. So as I make a short analysis, I want to present it to you here. Well, who are we? We are two companies. RDC is an engineering company that designs structures with UHPC, with a material, a type of concrete that can be lighter and more durable than ordinary concrete structures. And the precast company Preform. It's a company where we produce precast elements with this UHPC, our UHPC, which is called Formex. What is our approach? What is our way to provide a sustainable approach? We use less resources than building ordinary concrete structures, and our approach to durability is not only to build more durable structures, but also to design modular and easily connectable structures. Why? Because it is not enough to give 100 years of lifespan to a structure. It's also very important that if in 10 years a politician decides to change this structure from location, we can decommission it and install it in another location. It's important that we don't need to destroy it. So then we can guarantee that the structure can be reused. Okay, this is our approach. And also our approach is to try to build sector that follows decarbonization with UHPC. So we are not only in the construction sector, we are trying to approach fisheries, aquaculture, renewable energy sector, industrial sectors with higher added value than construction. As you can see in this plot, the amount of Formex that we are installing per year is higher and higher every year, and this means that little by little we are closer to, we are being more competitive with this innovative material. Well, where UHPC makes sense? Well, it makes sense where other materials are not very competitive or have weaknesses. This is a ternary diagram that I proposed years ago, and that is one to understand where it makes sense, UHPC. And it makes sense there where durability provides a competitive advantage, having higher durability. There where having higher lightness, where being light provides a competitive advantage, or there where being slender provides a competitive advantage, or makes that the client pays more for the solution, or in application that combines many of these things. For example, today we are going to speak about floating farms. Floating farms require a lot of durability because they are in an aggressive environment, but it's also very relevant to be light because we need to float them with steel floaters. So both factors provide a competitive advantage because UHPC allows you to do lighter structures. So thanks to the UHPC, you can design this solution. In the case, for example, of footbridges, it is important to be durable, particularly next to the sea. It's important to be light because it facilitates the installation, but it's also important to be slender because then the footbridge is beauty. So in these kind of applications, UHPC makes sense. And we have designed them in, well, we have designed many different UHPC applications, some of them very silly, because in order to do brilliant applications, sometimes you need to try, and sometimes you do silly things, but we have done many, and also many of them are really intelligent and worth. And today I'm going to speak about this one, about the aquaculture farms. We have already installed more than 15,000 square meters of this, and I'm going to explain how the European project has supported us to reach the market. Well, what was the problem that we identified in the year 2015? The floating farms that are in Galicia, Galicia is the producer of half of all the masses from the European Commission, have a problem because these structures are made of wood, and the wood is economic, is flexible, and this is good for the mid-oceanic conditions, but it also requires yearly maintenance, and the durability of these floating structures is very low. So in the end, there are problems of resiliency, and the partners need to spend a lot of money, and they have incertitude when a storm comes. So Well, this makes that producing this kind of funds is not very competitive, but also this kind of production, the production of these funds is not industrialized. The wooden logs are too long to be exported, so these kind of companies that produce these funds cannot export to other countries, and this solution is only adapted to Galician waters. Okay, so also as the installation system is very traditional, these kind of companies cannot sell abroad and they cannot scale up the business. So in the end, this is also bad for the Spanish economic system because the company cannot grow. Then in 2015, we decided to launch a solution without wood, which was made of UHPC pre-stressed beams. This is a patented solution. Okay, and we started in 2015 this kind of race towards the market. Now we are in the market. In 2015, we started developing and we reached the market in 2018. We needed funds, as you can see in the part below. We made prototypes from very small prototypes to small scale prototypes to large scale prototypes, and now we reached TRL 9 and we're in the market. In this 3 years period, this is what we call the valley of death or the what am I doing period. It's the time when you are wondering, why didn't I listen to my dad and become a public employee until you reach the market, no? In this first period, luckily, we asked for support for the European Commission and we received funds. Funds to do what? To demonstrate under operational environment that our solution is viable and makes sense. But not only to demonstrate to the farmers, also to demonstrate to ourselves, because we thought it works, but we needed to prove it also to ourselves. So with this first project, Selmus, we proved the technical and economic viability of this. Once we reached the market and we started selling, then we applied together with Polinia and other partners to the Resilience Project, which is a research and development project that we needed to try to reduce costs and to understand better the competitive advantages of our solution. This is something that I couldn't do if I am not in the market, because I cannot invest that much and wait that much to reach the market. So we started this when we were already in the market. Okay. Then little by little we understand our competitive advantages, and only 2 years ago we applied for another project, the Open Mode project, which was mainly to diversify. Why? Because we are selling only in Galicia. One product in one region. This is very very brief to be very narrow to me. We need to diversify geographically and also by products. So we try to adapt our solution to another sea basins, also to try to meet new potential clients, okay, to try to scale up the business. So I will start with this first project, the project Selmus. What was the challenge? Try to introduce advanced concretes in another sector where they are using the most economic material in the world, the wood from the logs of eucalyptus. The challenge is that we didn't know the sector. It's the aquaculture sector, and we are civil engineers. So there is clearly a knowledge barrier. But we also, our clients also don't like concrete because they are from the sea and they have seen so many corrosion pathologies. So they don't like the idea of using concrete. There is also a competitive price barrier because the floating farms made with wood are half of the price of our solution. So we need to try to sell a product that costs double. And finally, there is a logistic barrier because the companies that build these farms, they are from Galicia. And the farms are all in Galicia, and I am 1,000 kilometers from Galicia. So it seems really crazy to try to enter into this market. So if we were really convinced about this, we needed to apply a shaping strategy. A shaping strategy means that we need to shape the sector. We need to build the sector. We need to speak with the clients to understand what they want and also to understand what we need to design. So we're speaking with the farmers, understanding what they really need. We did 4 different pilots, full-scale pilots, more than 500 square meters, in the Atlantic and in the Mediterranean Sea to demonstrate to the farmers and also to us that it works. Luckily, now after 6 years, these UHPC floating structures are the most sold in the market. So we are market leaders. And what is the key? Considering that there are so many barriers, how this was possible? And how this will be possible with UHPC in other sectors? Well, because the client, the person that is paying, is also the user and the maintainer. So they are suffering the yearly costs of the maintenance. So after 2, 3, 4 years, they really notice the savings. They are telling, oh my God, this is more economic. So after 4, 5, 6 years, everyone is coming to purchase our raft because it is really the most economic. What is a shaping strategy? A shaping strategy is this. Is installing cameras, the pilots that we are using, and showing to the farmers that even with the craziest storm in the Atlantic, our structure works, and also showing it to ourselves. It is organizing events to speak with them, to shake their hands, to listen to them. It is coming onto the raft, visiting the raft, observing and recognizing the problems of our rafts. So this is shape a market. Understand together big part of the clients and try to create a product that they feel that they are part of. Okay. Well, after reaching the market, thanks to this Sermos project, then it became the Resilience project, a project where we were able already, because we were in the market, we were already more calm, and we were able to do R&D, research and development, to gain competitive advantages. The goal was to try to understand if we can reduce the cement contents, the steel fiber contents, if we can mainly reduce the costs, not only to make more money, but also to reduce the life cycle, to reduce the impact of our solution. With less cement, we are more sustainable. The question is, UHPC is very durable, but maybe our solution is too durable. Maybe we can do it a little bit less durable, we can be less conservative, and it will be excellent in any case. So this is what we try to guess here. What is the real durability of our structure? So what we did is a structure where each of the secondary beams has a different capacity. They have different type of cracking, different amount of cement, different crack width, different restressing, and we have monitored the durability of these elements, so we are understanding really how durable they are. So soon we will really have values, data, to understand if we can be a little bit more sustainable and also economic, to try to sell these elements for lower costs and reach a larger amount of farmers. This structure is under real conditions. We are producing oysters in the structure, as you can see here, not me, but a farmer. So it's a 540 square meters structures. The beams were pre-cracked in the factory. We pre-cracked them on purpose. We have there also a remote camera control. We are doing periodic inspections. The monitoring has been implemented by us, by UPB and the CSIC, and also Stress has led a comparative life cycle assessment between our structure and the wooden structure. Our structure is more sustainable, basically because the wooden structure needs to apply so many yearly maintenance, and this increases the carbon footprint of the solution. Here you can see that our structure is already in Google Maps, as you can see in the path up in the right. Well, and after that we applied to the Open Mode project, a project from the European Maritime and Fishery Fund, which has helped us mainly to bridge our difficulties to sell abroad, to do the internationalization of the company. What was the first barrier to go abroad? Well, the elements are too big. The beams have 27 meters of length, and try to export to South America or to Australia so long elements is crazy, doesn't make sense. So we need to be able to sell these elements with 12 meters long, so then we need to be able to connect them. So we developed a kind of connection that is also patented, as you can see here, this is the number of patent. And this kind of connection is only viable with these sizes with UHPC, because UHPC has such a high bonding strength that we can concentrate all the capacity, all the tensile capacity of the steel elements in such a small area. Okay, so this kind of connection is only viable like this. And in the end, the goal and the demonstration was that we made floating structures that were shorter, and we were able to connect them inland and also on the water, as you can see in this figure. Thanks to that, well, we have access to new markets, for example, to Morocco. Now it is viable to us to sell in Morocco in the new farming locations, something that years ago was impossible with wood. Well, the second challenge was to try to provide a solution that is worth for farmers from other locations. In Croatia or in Montenegro, for example, the sector is more atomized. I cannot sell such a big platform because only one farmer harvest lower amounts of shellfish. So we propose simply modules that are really easy to be installed, that were 12 per 12, so I can sell them in a container. This first is an example of the installation that we made months ago in Croatia, and the second one is one that was done in Montenegro, where we are now being able to measure the differences of our intensive farming system with the typical traditional farming system that they have there, which is the long line system. Okay, so we are shaping these sectors also through trainings. We have online trainings for free where the partners can read, observe how the works are done, and they are learning how to change from this typical farming sector, which uses so much plastic, to our solution that doesn't use plastic in this environment. Here you can see a small video of this installation that we made in Croatia in May. This was a challenge to us because we were not used, and also the installers from Galicia, they were not used to do these operations in foreign markets, to hire a crane, to have access to a boat. For example, this boat, this is a local fisherman. We asked him to help us to pull from the raft. So you need to, in this kind of remote locations, you need to count with the tools that they have. Okay, this is the first raft installed in the Adriatic. They didn't have raft before because they were not used to this solution. And it is helping them because here they can put a perimeter net that avoids that the fishes eat the harvest. And it was a big problem that they had in the past with the long line, so now they can really protect the harvest from the ducks and the fishes. What more can we done with UHPC that couldn't be done without the solution? This is a submersible raft for the North Sea. What is the problem in the North Sea? In winter, there is an ice layer. If you have a floating structure with an ice layer, the ice breaks it. So here, and thanks to the Resilience Project, because in the Resilience Project, in the pilot, we already started designing floaters that were submersible. So here we made a submersible floater. These floaters can be filled with water, and then the structure, as you can see here, we sink it to the bottom. This happened 2 months ago, and when the ice melts in April, the structure rises again. It's something that we couldn't do with wood, because wood gets saturated and it would get destroyed, but the UHPC has the capacity to be in this environment. So it's a new ability not only for ice regions, but also for regions as in Chile, where the visual intrusion is starting to be a big problem for the tourists. So you can hide the structure, and when you need to take the harvest, you can put it out. And finally, another solution, another development that we made in the Open Mode project, our structure normally has a weight 20% larger than the wooden structure. We tried to develop a solution that it has exactly the same weight as a wooden structure. And this is what we have made here. We have reduced the weight of the beams and the number of the beams, and this is a more competitive solution, particularly because now we don't need to change the steel floaters. What was the problem? The increase of the price of the steel has made us less competitive. So we needed a solution where we don't need to change the steel floaters so we can compete. And this new solution is a little bit less weak than the typical floating farm, but it works for 70% of the estuaries where the waves don't have 4 meters of height, they have maybe 1 or 1.5 meters of height, so we are facing new sectors. In fact, here you can see, and this is myself, I can't believe that I have put in this video, but I am starting to be very open. You can see here the flexibility of this kind of structures. It seems like it's weak, but here where I am jumping, you could apply 500 kilos, 1,000 kilos. It would bend a lot, but it wouldn't break because it's really highly stressed. And UHPC allows you, the microgravity allows you to design these kind of structures. And this kind of building is something that we have introduced in this type of structures. They adapt very well to the soil, and they are also lighter. Okay. So finally, and to finish, here I am going to answer the key question about the return of the investment. Is it worth the money that the European Commission has invested in us? Well, the solution that I am showing is aligned with at least 4 Sustainable Development Goals. We are promoting the blue economy using a compound and inorganic material in the sea. We are promoting inclusive employment in the European Union because 100% of our product is produced, manufactured in the European Commission, in the European Union, and with raw materials from the European Union. We are promoting sustainable and not-fed and economic protein. Mussels have 80 times less carbon footprint than beef, so it is a very sustainable protein. This is what we are promoting, and we are promoting the food production in a sustainable way. In the end, with these 3 projects, the Selmus, the Resilience, the Open Mode, the European Commission has invested 1.2 million in this project. Okay, and up to now, what did we generate? Only in the turnover of our company in UHPC rafts, the turnover has reached 2.8 million, so more than double. The value in mussels, in low carbon footprint protein, already reaches 12 million euros in 3 years. Okay, we have avoided more than 8,000 liters of paints and coatings to the sea, and now there are 4 employees working in Perform. This is only in 3 or 4 years, so I guess that little by little, this benefit, this return will be higher, and I can say that I consider that the investment from the European Commission in our idea has been really worth to us and to the society. And this is everything from my side. Thank you.
Thank you, Esteban.